Hello, my name is Daniel Aiku from class A2 and I am a student in UITM Cawangan Pulau Pinang campus Batam. I am taking on the course of Diploma in Pharmacy and I am currently in semester 2. I am also the leader for our group Ok.Done for our Calculus 1 assignment, and here is my group members.
Assalamualaikum. Today I will introduce myself. My name is Muhammad Faid bin Alias from class A2. Course that I take is pharmacy, and place that I study now is UiTM Pulau Pinang, Cawangan Kampus Batam, and I am from group Ok.Done.
Hi and Assalamualaikum. My name is Muhammad Izzatul Zarin bin Majala. I'm from class A2 and I'm from group Ok.Done.
The introduction is students or anyone who learn calculus will be common with the problem statement of the maximum and minimum problem. Problem statement of the maximum and minimum problem are one of the application of differentiation in fundamental theorem of calculus. Application of maximum and minimum problem are not only can be used when we do the calculus question, but we also can use application of maximum and minimum problem in our real life. A lot of people will use this application to solve maximum and minimum problem in real life where values need to be maximized or minimized. This application will give a lot of benefits to human because human can save their times when they face this problem in real life. They can do their work in short period of time when they using application of maximum and minimum problem. For an example is you have 40 feet of fence to enclose a rectangular garden along the side of a barn. What is the maximum area that you can enclose? At the end of the result, you will get the maximum area that you can enclose your garden with the fence.
Now in this video there are three main objectives. First is to find the volume formula as the corners are removed. Second is to find the dimension of the box or cube. And third, to determine the maximum volume of the box or cube. So a problem states that a boy is creating a cube with an open top using a cardboard by removing squares of equal size from the corners of the cardboard piece and folding the sides upwards. If the piece of cardboard is 2 feet by 2 feet, what is the maximum possible volume of the box or a cube with an open top? Now the first thing I'm gonna do is that I'm going to draw a picture to get a better understanding about this situation. So the boy got a piece of cardboard with sides of 2 by 2 feet and he's going to cut out little squares from this piece of cardboard at each corners. Now the thing we don't know in this is that how big the little squares should be to make this box with a maximum volume. So because it is unknown, we put it X on the sides of the squares and we assume that the size is X by X. So the idea here is that the remaining flap is folded up to create this kind of box which I drew here.
Now we want to find the maximum volume of a cube. First, we need to find the volume of a cube. The width and the length of a cube is 2 minus 2x. This is because we need to deduct the side and this side with x. So we get 2 minus 2x. And the height of a cube is x, this one. And we get 4x minus 8x squared plus 4x power of 3. And then we do the first derivative from this equation. We get 4 minus 16x plus 12x squared. And we need to find the critical point, p prime x equal to 0. And we do the quadratic equation, which is 12x squared minus 16x plus 4 equal to 0. And if we factorize this equation, we get x equal 1 over 3 and x equal to 1. And next, we need to determine the minimum and maximum value. We need to do the second derivative from this equation, and we get 24x minus 16. At x equal 1 over 3, we found that it is the maximum value, and x equal to 1 is the minimum value. As we know from the first step, we need to find the maximum value of a cube. And the maximum value when x equal 1 over 3, and we substitute x equal 1 over 3 to this equation for x minus 8x squared plus 4x power of 3, and we get 16 over 27.
Conclusion is the volume formula of the square box is volume equal to length multiplied by width multiplied by height. The dimension of the square box using the first derivative test of differentiation are volume equal to 3x squared minus by 4x plus 1 equal to 0, and the value of the x is x equal to 1 over 3. The maximum volume of the square box is 16 over 27 feet cubed.